Welcome to the GoalZero Toolbox Talk series. Today's Toolbox Talk: Electrical Grounding. Electrical safety grounding is one way used to reduce the effects of electrical hazards on persons and equipment. Electrical safety grounding works by using the earth or ground as a conductor to drain away any unwanted electrical discharges. Besides power lines and the human body, particularly the human heart, electrical currents can travel through water, dirt, rocks, and anything else on the ground. This fact makes the earth the ultimate conductor and a great way to promote electrical safety grounding. In practice, if any electrical wiring becomes faulty, then the electrical ground absorbs a large portion of the straying electrical current instead of an electrical worker repairing or servicing electrical, computer or electronic systems. But, to achieve this, electrical circuits must be secured to the ground or the earth through a qualified electrical safety grounding system or network of systems. Electrical grounding. How proper grounding improves electrical safety. Secure electrical ground connections protect workers but also help protect the safe operation of equipment. Sometimes electrical equipment can be susceptible to electrical interference, but electrical safety grounding systems can protect against this. Also, if lightning strikes the building housing electrical equipment, a considerable amount of damage can be done, but electrical safety grounding, using the earth as a conductor, can dissipate any amount of electrical current. System components can also be damaged by electrostatic buildup, but electrical safety grounding helps to avoid damage by draining away any unwanted electrical current. A well-grounded point usually has a constant voltage, no matter what happens in the system or the circuit. Grounding systems and circuits. A few essential pieces of equipment are connected to make a good grounded electrical safety system. The grounded conductor, the grounded bus bars, the grounded conductor for equipment, and any other metal parts that don't possess electrical currents. This system is put together by joining an appropriately sized unspliced grounded electrode conductor between the grounded electrode system and the grounded bus bar. Bonding is defined as connected to establish electrical continuity and conductivity. Bonding metal parts, such as enclosures and raceways, ensure that they are all continuous on an effective ground fault current path, EGF-CP, that references back to the ground, earth. The EGF-CP helps operate devices such as circuit breakers and fuses or ground fault detectors in ungrounded systems. In grounded systems, it is important to bond the equipment grounding conductors to the system grounded conductor to complete the EGF-CP back to the source of electricity. The conductivity of the EGF-CP is critical for protective devices to work properly. This speaks to why we scrape the paint from contact surfaces of metallic enclosures to make our electrical system bonding connections. What is utility grounding? Electric workers, especially linemen, use grounding systems regularly as a protective measure against electric shock. Many electric utility workers have been performing certain grounding principles for decades, but in recent years some safer practices have been discovered. It's important to stay on top of these changes. Grounding to protect employees has two main requirements. The first requirement is to cause immediate operation of protective devices in case of accidental energizing of the lines or equipment. The second requirement is to prevent each employee from being exposed to hazardous differences in electrical potential. It's important to note that utility grounding is different from permanent grounding. Permanent grounding systems in buildings are installed so that no current flows except in fault conditions. However, in utility grounding systems current always flows, even on permanent grounds.